Hi everyone, I want to give you a video to help you to understand the calculation part of titration lab. So first you need to read over the background of that lab report, right? It gives you a lot of information about titration, about the specific acid and base we're using. So in general, titration is for neutralization of an acid and base, right? So basically, when the titration is done, the amount of proton concentration and amount of hydroxide concentration needs to be proportionally as the stoichiometry. And you might not know this is a titration curve, which on the y-axis is the pH within the flask, the pH which you have the indicator in, right? And then the horizontal, the x-axis, is the amount of in our case is sodium hydroxide that you have been added from the burette. So when it started, it has a acid, right? So the pH is low. And then when it reached a point, which is called the equivalent point, when, as we said, when the concentration of hydroxide and proton are the same, that's called the equivalent point, and that's when the indicator will change color, right? And then after that point, if you add more, it will become more basic, like here. So in this experiment, the first part is we're gonna use a known amount of an acid called KHP and react with the NaOH solution you got to figure out the concentration or the molarity of a NaOH solution. And you should read information of the package to understand why we need to standardize the and just to mention, as I mentioned before, that equivalent point, that the concentration of hydrogen and hydroxide are equal to each other, right? So if we look at our reaction, KHP react with NaOH, and it will form water, right? So the OH and the H will come out, so sodium and KP will form a salt. Here is what we're doing for the first part. I don't know if you can see this, but for basically you have this burette, right? And then you start with this initial volume, VI, right? And then you have the KHP, the measured known amount mass of KHP dissolved in water here. And you have indicator in this too. And once you started adding this NaOH inside here, it will gradually turn pink, right? At the beginning, when you swirl it, the pink disappears. But the equivalent point is when this pink stays for at least 20 seconds, right? You also don't want to add too much of it. It stays like hot pink. That's called over titration, which means you added too much of this basic into this acid, right? So for your measurement, you need to measure the amount of KHP that you dissolved in the solution and the initial volume. And then when it reached the equivalent point, when it just turned pink for 20 seconds-ish, what is your final volume, right? You need this two volume to find the amount of NaOH you used, which is the final volume minus initial volume. Okay, and another thing I want to point out is how you read a burette. You will notice burette at the very top, when everything is full, it says 0 there, right? And then it goes higher, all the way down is 50 milliliter for us. So if you have something that's like have this curve right here, and when you read from top down, right? So here it wouldn't be 2.5. Instead, this will be 1.5 because you're reading this one and then down another 0.5. Okay, so you need to make sure that you have the right reading for your burette. Okay, and then once you get all the data, there's 3 of you or 2 of you in a group. You need to have set data 1, 2, and 3, 1 per each lab name. Okay, so once you know the mass of KHP, right? Because we measured it. That's when we started. And if you use molar mass of KHP as a connection factor, you can conversion factor. You can convert it to mole of KHP, right? Once you know mole of KHP, you can use mole ratio to get mole of sodium hydroxide. In this reaction, they are 1-to-1 ratio, right? And then once you know the mole number and you know the volume of NaOH you use, you can calculate the molarity, right? Molarity is equal to mole per volume in liter, right? So therefore, you can calculate the molarity of NaOH as the result of part 1. Because in most groups, there are 3 of you, so you need to use the average molarity, which add up all 3 of them and then divide by 3. And this average molarity is your experimental data. For theoretical data, you would find the difference between theoretical and your experimental and divide by experimental and then convert it to percentage. For the second part, titration, you will be giving a certain amount of acid, right? It could be HCl, it could be acetate acid. So this volume is whatever you receive for that part. And then you will perform the same titration, right? You start as the initial volume, and once you start to adding this NaOH, the same NaOH you used for part 1, right? As you keep adding in, to a point, it will reach the end point, which indicator will turn pink, and you should record this final volume too, right? So this is how you use the burette. At the beginning, it's clear. Once you add it, you will see some pink, but once you swirl it, it disappears. And the final end point is when it stays pink, but not too hot pink, okay? So for this, as we mentioned, you will measure the volume of the acid you received, right? And you will measure the initial volume and the final volume for the NaOH. You can figure out the amount of NaOH you used. And then because now you already know the molarity of NaOH from part 1, right? Once you use that times the volume of NaOH used here, you can get the mole of NaOH you used for part 2. From mole of NaOH, using mole ratio, you can find mole of acid, whichever acid you are using for this part. And then you can use volume of the acid, which was given at the beginning, right? You have that value. You can get the molarity of acid. Molarity of acid is equal to mole of acid divided by volume of acid in liter, right? And the same way you can calculate the percent error. So good luck.